Hello, let's talk about growing patterns. Today we'll talk about arithmetic/linear growing patterns. So first of all, arithmetic sequences. Maybe this sounds familiar, maybe it doesn't. Either way, these occur when the first difference is constant. Okay, we'll talk about what that means in a minute. And so with this kind of sequence, actually any kind of sequence, you can come up with an explicit formula. And this formula will be in the form y equals mx plus b. Familiar? Probably, right? This is just slope-intercept form for a line or a linear equation. And for arithmetic sequences, our slope, or our m, is actually going to be our constant difference. And our b is going to be like our zeroth term. It's not really a word exactly. It's basically the amount at stage 0. We'll talk about that when we do examples. And we also have a recursive formula. And when you define something recursively, it means you're finding values based on values you already have. So for this y equals mx plus b, you can plug in any x value and you can come up with your term. For recursive, you need the term before. So a sub n, a for arithmetic, that's why we'll use a, equals a sub n minus 1 plus d. And our a sub n minus 1 is just our previous term. And our d is going to be our constant difference. Okay, let's do an example. Actually 2, but we'll start with, 1 because we can't do multiple things at once, probably. Let's say we have the sequence, I like this pretty blue color, -4, -2, 0, and 2. Okay, so if we look at this, first we'll find our constant difference, because generally with sequences that's what we'll do. So -2 minus a -4, second minus first, that just equals 2. 0 minus -2 equals 2, and 2 minus 0 equals 2. So then our constant difference, I'm going to call it a CD, is 2. So the other thing we need for our explicit formula is our zeroth term, or like the 0th term. Basically, when we look at this, -4 is our first term, -2 is our second term, 0 is our third term, and 2 is our fourth term. And we want to find what term 0 would be. And the easiest way is just to look at our patterns. There's a bunch of 2's. So we need another difference of 2. So basically, if we look at it, we want -4 minus something to equal 2. But also, if you look at it backwards and just look at the pattern, it's subtracting 2 as we go to the left. So this should be -6. And just to check, -4 minus -6 should be 2, and it is. So then our 0th term is -6. So then our explicit formula will be y equals, and our m is our constant difference, so 2x plus our 0th term, which is -6. You could just say y equals 2x minus 6 as well. That's probably what I would do. Plus -6 is also fine. And now to check, you should be able to plug in any of these term numbers and get your value. So let's look at term 3. This means that if we plug in 3 for x, we should get 0. So let's see. Term 3, y equals 2x minus 6, y equals 2 times 3, because again that's our term number, minus 6. 6 minus 6, that's 0. So our third term should be 0, and it is. So that's kind of one way to check if you did it right. All right, let's do another example. This time we'll have a picture. So let's do green. So for our picture, we have, let's say our first term is a box, and one box on top of it. And our sequence, and pretend those boxes are the same size, even though they're not. Essentially, our sequence is going to start with the same shape and just add a box on top. So start there, add one more box up there. Add one more box. So essentially what's happening is you start with this 3 and you keep adding 1 on top. So that's really what our pattern is. And so since we're adding 1, you can probably guess that our constant difference will be 1, but let's go through and do it anyway. So this would be 3, this has 4 boxes, 5, and this has 6. So then 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. So our constant difference is 1. Now we need our 0th term. And so you can think of it a couple different ways. You can think of it either how your picture would look, or you can think of it as a number pattern. So if we think of it as a number pattern, it's going up by 1 to the right. So what number do you add 1 to get 3? 2. But you could also just draw your picture, and it would have started like that, and we would have added our box on top. So it's up to you. So our 0th term is 2. So now for our formulas, our explicit formula would be y equals our constant difference, which is 1x, plus our 0th term, which is 2. I'd probably drop the 1, but you can keep it if you want. Y equals, oops, it'd help if I could, write what I was meaning to write. Y equals x plus 2. And then if we look at it recursively, a sub n, basically any prior term, you just add 1 to it. So that's our recursive formula. So look up here at the picture, what happened? Well, if you start at 3 to get to the next term, you add 4. If you start at 4 to get to the next term, you add 5. Okay, so any given term, you add 1. We're going to go back up here because I totally forgot the recursive formula for this other one. So recursively, again, using each prior term, we're looking at like what happened. So we have a sub n, so like the nth term. You take the prior term, and what do you do to it? You add 2. And this should hopefully make sense, because if you look up here, if you take negative 4, which is like a1, or I'm sorry, yeah, if you take negative 2, which is a2, you would take a1 and add 2 to it. Okay, so every prior term you'd add 2. To get to 0, you add 2 to the second term. To get to 2, you add 0. To get to 2, you add 2 to the third term. Okay, so that is how that works.